potential fuel for rockets is B5H9 and O2. If one tank holds 126 grams of B5H9 and another holds 192 grams of O2, what is the mass of water produced? And here is the balanced chemical equation. 2B5H9 liquid reacts with 12O2 gas, and it produces 5B2O3 solid plus 9H2O gas. I'm given grams of the two products. So what I must do is convert them to moles, figure out which one is the limiting reactant, then use a mole to mole ratio, figure out how many moles of water is produced for how many moles of reactant I have, and then convert the moles of water to grams. First I need to convert these to moles. 126 grams of B5H9 and 1 mole of B5H9 is equal to 63.14 grams. And this is equal to 2.00 moles after rounding. Now I need to figure out the moles of O2. Space. O2 is 31.98 grams per mole. And this ends up being, after rounding, 6. Now that I know the moles of each, I need to figure out which one of them is a limiting reactant. I'm just going to pick oxygen because I did it last. I can pick B5H9 if I felt like it. And I'm going to figure out how many moles of the other I would need to completely react the oxygen. I have 6.00 moles of O2. I'll go back up to the chemical equation. 12 moles of O2 is needed to react with 2 moles of B5H9. Six divided by 12 is 1/2. 1/2 times 2 is 1. Now I take this and I go back and look how many moles I have of the other, and I see that I have 2. So in order to completely react this 6 moles, I only need 1 mole of B5H9 and I have 2, so therefore oxygen is the limiting reactant. Now since oxygen is the limiting reactant, I'm only going to get 6 moles of products of however this ratio turns out being. And I'm only interested in water in this example. So I'm going to take 6 moles of O2 for every 12 moles of O2. I get 9 moles of H2O. This is going to be 4.5. Now I just convert this mole value into grams using the molar mass of water. And this equals 81 grams of H2O.